When a short circuit or overload occurs, electricity seeks the path of least resistance. The main breaker may have a lower trip current than the subpanel breakers, which would mean when a fault occurs, the electricity will flow through the main breaker and trip it before it reaches the subpanel breakers. Possible causes of the main breaker tripping may include a short circuit. This is a direct path between the hot and neutral wires. It could also be an overload, which means drawing more current than the circuit is designed to handle. A ground fault is also possible, meaning current is leaking from the hot wire to the ground wire. The proper course of action to troubleshoot starts by checking the subpanel breakers. Ensure that none of the subpanel breakers are tripped. If they are, reset them and see if the main breaker still trips. Next, test the subpanel circuits. Use a multimeter to test for voltage and resistance on each circuit. Look for any abnormal readings or loose connections. Inspect the conduit. Check for any signs of moisture, damage, or corrosion. If the conduit is compromised, the wires may be damaged or shorting out. Check the main panel. Verify that the main breaker is properly sized for the subpanel load. Ensure that the main panel is also in good condition and not overheated. Measure the current. Use a clamp meter to measure the current draw on the subpanel feeders. If the current exceeds the rating of the subpanel breaker, it could be causing the main breaker to trip. Additional troubleshooting tips may be needed. Use a circuit breaker finder. This tool can help identify which circuit is causing the main breaker to trip. Test with a ground fault circuit interrupter. Plug a ground fault circuit interrupter into an outlet on the subpanel and see if it trips. This can help identify a ground fault. If unable to troubleshoot the problem, it is best to contact a qualified electrician for further assistance. It is important to address the moisture issue in the conduit, which can lead to further electrical problems and safety hazards. Consider drying out the conduit or running new wire in polyvinyl chloride pipe to prevent future problems. First, ensure all safety precautions are taken when working with electrical systems. Always de-energize circuits before performing any tests or inspections. Second, thoroughly examine the wiring within the subpanel for any signs of damage such as cracked insulation, corrosion, or loose connections. These issues can create short circuits or ground faults that trip the main breaker. Third, pay close attention to the outdoor lighting circuits and pool equipment connections, as these are more susceptible to moisture and corrosion. Check the junction boxes, light fixtures, and pool equipment for any signs of water intrusion or damage. Fourth, verify the ampacity of the conductors feeding the subpanel. Use the appropriate American wire gauge size based on the 100 amp breaker in the distance of 150 feet to ensure voltage drop is within acceptable limits, typically 3% or less. Fifth, calculate the total load in the subpanel to ensure it does not exceed the 100 amp rating. Consider both continuous and non-continuous loads, and apply the appropriate demand factors as per the National Electrical Code. 6. Examine the grounding system for the subpanel to ensure it is properly connected and functioning. A faulty ground can cause ground faults and trip the main breaker. 7th. Use an insulation resistance tester, also known as a megometer, to check the insulation resistance of the conductors feeding the subpanel. Lower insulation resistance indicates damaged insulation and potential for short circuits or ground faults. 8th. If the subpanel is fed by an underground circuit, consider the possibility of cable damage or water intrusion along the buried portion of the conduit. This can be difficult to diagnose without excavating the conduit. 9th. Check the neutral to ground bond in the subpanel. In a subpanel, the neutral and ground conductor should be isolated, with the neutral bonded only at the main service panel. A neutral to ground bond in the subpanel can cause unwanted current flow and trip the main breaker. 10th, if the problem persists, consider using a power quality analyzer to monitor the voltage and current on the subpanel feeders over time. This can help identify intermittent faults or unusual load conditions that may be causing the main breaker to trip. Continue by elaborating on each of the original troubleshooting steps with more detail. For checking the subpanel breakers, physically inspect each breaker for any signs of damage or overheating. A visual inspection can sometimes reveal a faulty breaker. Use a multimeter to test the continuity of each breaker in the off position. A breaker that shows continuity in the off position is likely defective. When testing the subpanel circuits, start by energizing the circuit and checking for continuity between the hot and neutral conductors. A low resistance reading indicates a short circuit. Next, check for continuity between the hot and ground conductors. A low resistance reading indicates a ground fault. Use a voltmeter to measure the voltage at each outlet and light fixture. A voltage reading that is significantly lower than the expected voltage indicates a voltage drop problem. When inspecting the conduit, look for any cracks, breaks, or corrosion in the conduit. These can allow moisture to enter and damage the wires. Check the conduit fittings to ensure they are properly tightened and sealed. Loose fittings can also allow moisture to enter the conduit. If the conduit is buried underground, consider the possibility of root intrusion. Tree roots can damage the conduit and the wires inside. When checking the main panel, verify that the main breaker is properly seated in the panel. A loose breaker can cause overheating and tripping. Inspect the bus bars in the main panel for any signs of corrosion or damage. Corrosion can reduce the conductivity of the bus bars and cause voltage drop. Ensure that the neutral and ground connections in the main panel are tight and secure. Loose connections can cause voltage fluctuations and tripping. When measuring the current, use a clamp meter that is rated for the appropriate amperage. Clamp the meter around each of the hot conductors feeding the subpanel. The meter will display the current draw on each conductor. Compare the current readings to the rating of the subpanel breaker. If the current exceeds the breaker rating, reduce the load in the subpanel or upgrade the breaker and wiring. To elaborate on the use of a circuit breaker finder, plug the transmitter into an outlet on the circuit that is causing the main breaker to trip. Use the receiver to scan the breakers in the main panel. The receiver will beep or light up when it is near the breaker that corresponds to the circuit with the transmitter. Once the correct breaker is identified, investigate the circuit for any faults. To elaborate on testing with a ground fault circuit interrupter, plug the ground fault circuit interrupter into various outlets and the subpanel to see if it trips. If the ground fault circuit interrupter trips consistently at a particular outlet, there is likely a ground fault on that circuit. Disconnect any appliances or devices that are plugged into the outlet and test again. If the ground fault circuit interrupter still trips, the problem is likely in the wiring. When contacting a qualified electrician, be prepared to provide them with as much information as possible about the problem. This includes when the main breaker trips, what loads are connected to the subpanel, and any recent electrical work that has been done. A qualified electrician will have the tools and expertise to diagnose and repair the problems safely and effectively. Next, discuss the importance of addressing moisture issues in the conduit. Moisture in the conduit can cause corrosion of the wires and electrical connections, leading to short circuits, ground faults, and other electrical problems. Moisture can also damage the insulation on the wires, increasing the risk of electrical shock. If the conduit is filled with water, it can freeze in cold weather, causing the conduit to crack or break. To address the moisture issue, consider drying out the conduit using a wet/dry vacuum or other suitable method. Seal any cracks or openings in the conduit to prevent moisture from entering. Replace any damaged or corroded wires or electrical connections. If possible, run new wire and polyvinyl chloride pipe instead of metal conduit. Polyvinyl chloride pipe is resistant to moisture and corrosion, and it is easier to install than metal conduit. Ensure that the polyvinyl chloride pipe is properly sealed and supported to prevent moisture from entering. Consider using a conduit sealant to seal the joints and fittings in the polyvinyl chloride pipe. In addition to the above, consider these points. First, check for any signs of rodent damage to the wires or conduit. Rodents can chew on the wires and insulation, causing short circuits or ground faults. Second, if the subpanel is located in a damp or humid environment, consider installing a dehumidifier to reduce the moisture level. Third, if the subpanel is used to power sensitive electronic equipment, consider installing a surge protector to protect the equipment from voltage spikes. Fourth, If the subpanel is located in an area that is prone to lightning strikes, consider installing a lightning protection system. 5th, regularly inspect the subpanel and the surrounding area for any signs of electrical problems. Address any problems promptly to prevent them from escalating. 6th, keep the subpanel clean and free of debris. Dust and dirt can accumulate on the electrical components, causing them to overheat. 7th, ensure that the subpanel is properly labeled and that all circuits are clearly identified. This will make it easier to troubleshoot problems and perform maintenance. 8th, if you are not comfortable working with electrical systems, hire a qualified electrician to perform the troubleshooting and repairs. Working with electricity can be dangerous, and it is important to take all necessary safety precautions. 9th, keep a record of all electrical work that is performed on the subpanel. This will help you track any problems that may arise in the future. 10th, familiarize yourself with the National Electrical Code and any local electrical codes that apply to your area. This will help you ensure that your electrical system is safe and compliant. In conclusion, troubleshooting a main breaker tripping before subpanel breakers requires a systematic approach. Start with the basics, such as checking the breakers and testing the circuits. Then, move on to more advanced techniques, such as inspecting the conduit and measuring the current. If you are not comfortable performing these tasks yourself, hire a qualified electrician. By following these steps, you can identify and resolve the problem safely and effectively. Remember to prioritize safety and always to energize circuits before working on them.